Okay, good morning. Week 3 of our 8-week format for ITS836, Data Science and Big Data Analytics. I'm Dr. Walker, and I'm going to talk a little about the weekly objectives straight out of the classroom. Just some of my thoughts on data visualization fundamentals and and how you approach them, what they mean to you now that you're a PhD student. And then we'll go over the assignments. And again, because of this 8-week format, we're not the weekly objectives are all about data visualization, and the assignments, the discussion and the paper have nothing to do with visualization. So the content does not match the assignments. So I'm going to just talk just to get you started, on all of that, and it'll be fine. Okay, so the weekly objectives describe how visualization helps in predictive modeling. There are some techniques that are perhaps more accurate in forecasting or predictive modeling than visualization, but a trend line will show you, past the past history of a given data item, or pair or trio of data items, and show you if they're gradually increasing over time and decreasing over time, and if there's some cyclicality. There are some graphs out there. If you look up graphing seasonal data, cyclical data, you can see in the trend line that there's a bump, whatever, every beginning of every year, in the middle of the summer, where there's a dip because of seasonality of processes. Number 2, explain data visualization. Well, I got a chart on that next, so I guess that's the one part of the thing that we'll actually talk about. Business intelligence is just taking business data very often in real time or near real time, and presenting it to decision makers, generally in a dashboard format. Like, they're driving their business like you're driving a car, and they need to see, inventory levels compared to sales, recent and projected not too far into the future. Could be some HR in there, an HR dashboard showing when people are slated to retire, people that have already put their notice in, new hires that are in the pipeline, number of applicants they've had against different job openings. So yeah, business intelligence is decision critical information presented in a fashion where decisions can be made now and about the future, but really more about now, really. And the most common tools are Microsoft Power BI. It's kind of like Excel, with a lot of enhanced functionality, that lets you do a dashboard with different tabs on it. All of these tools are a quick YouTube away if you've never seen them. That's Power BI. Tableau is the other, arguably larger desktop application for business intelligence dashboards and ingesting static and dynamic data and displaying it to the user. There are others. I've got a organization that uses one called Domo. They're listed in your your content folder. Um, Again, identify types of analytic models. There's some of that in the reading that you're doing this weekend, but we're not really talking about any of that. But an analytic model can be anything from um, a simple Pearson's correlation line of best fit, where you kind of can see as the X increases what happens to the Y. That's, a simple analytical model. But it could be, you got categorical data. So it could be that, 75% of smokers are male. So we need to target men with anti-smoking campaigns if we want to do something about it. There's, proportions, but then there are, more advanced. There's clustering algorithms, which it's an unsupervised machine learning technique that again, that's an hour or two YouTube video away if that's in your future. Um, and then how big data models within business intelligence. That's um, the core of the one of the assignments. We'll talk about that. Um, Traditional business intelligence uses structured data to inform business leaders. And then big data came in and forced business intelligence developers to use that data and update. So, you could have a dashboard for, a large company, say, Ford Motor Company. And along with production numbers, how many pickup trucks and sedans are cranking out of the assembly line, how many online orders have happened on the website. This could be all in real time. You can start throwing things like sentiment analysis and uh, trending hashtags and things off social media, trending posts. If you're doing a social media ad campaign, you could, like, in real time, you could count the number of shares smoothed over the last hour or whatever, to kind of see uh, literally in real time what's going on with your brand, with your entire company, both the way people perceive it and what's happening operationally inside the company. So yeah, it's integrating big data factors into a traditional business intelligence program. And there are some case studies out there. If you search, big data and business intelligence separately, and get both of those into a title search, you'll see several case studies out there. But the bottom line is to think about data visualization like a researcher. When everyone introduced themselves, uh, they did so, it seemed to me, thinking you were going to learn data science as a practitioner and learn how to do data science. And unfortunately, that's not what a PhD course is for. That's not what a PhD program is for, really. It's not really supposed to make you a better practitioner of the technology. It's supposed to make you a researcher of the technology. So, again, this week, you've got a good video from Dr. Brown of converting your research idea into an actual executable research question. And again, the word research is used very loosely, like these research papers that you're writing. are literature reviews, really. So, in fact, the instructions call them, you will write a literature review. You're not doing any research, not really. If you were to do a no kidding systematic research and start quantifying the number of papers that were written for, with a qualitative research approach and a quantitative research approach, and you started counting word length and how many times they'd been cited and how many times they'd been read, and started quantifying the literature for a given purpose or in a given topic area. That is research. But just writing about a topic, that's not really doing research. But think about data visualization like a researcher. How would you describe a phenomenon or a problem or an opportunity, and then pose research questions that could be answered, like what percentage of executives consume business intelligence on a daily basis? Well, and then maybe a follow-on research question might be, what is their perception of the necessity of the business intelligence? It could be a qualitative project where you find out, what people that are using business intelligence, leaders that are using business intelligence, and then you interview them to ask questions about what it's doing for them. Is it good or bad? If it's bad, why is it bad? What could be done to make it better? And so on and so forth. But researching these topics is why you're here, learning just enough about them that you can craft a research project in that area. You're not here to become an expert in the topic. I know it's counterintuitive. Okay, so data visualization, it literally is just taking numbers, and we've all seen spreadsheets where you cannot, even combing through it and reading, the data, if the data gets to be more than three or four items, you can't see like the distribution of the data. You can't see the predominant values. You can't see outliers. So data visualization turns numbers into representations the brain can quickly absorb. Or from one of the articles, its data visualization techniques are authenticated scientifically as 1,000 times reliable rather than textual representation. They may have removed that article finally, but that's a person's attempt at saying a picture is worth 1,000 words. So there are many, many, many examples of data visualization. One we all deal with all the time is a map. You have symbology, you have embedded, global location, latitude and longitude. But then there's all kinds of, the different colors, green for public spaces, and you might have dots on the map. The larger the dot, the bigger the city. You've got different symbols for the roads connecting, and different symbol for a railroad from a road. The symbols for the roads are thicker as the road gets more formal, from neighborhood road up to interstate highway. And then of course, we've all seen all the Excel charts. So again, if that's what your research interest is, it couldn't hurt for you to do a refresher on Excel chart types, and then maybe advanced chart types, advanced visualizations that are not part of Excel. Line charts, bar charts, pie charts, of course, scatter plot, and you've got heat tables, heat maps that show proportionality. So not every graph is good for every type of data. I saw somebody trying to scatter plot categorical data, and they just didn't realize what type of graph is good for what type of data. So if you're weak on that, hit the YouTube. But then it gets, super complicated from there. Um, VR interactive, you're walking through the data like Tom Cruise in Minority Report. You're actually interacting with data visualizations in 3D. Really cosmic stuff that folks are working on out there. Um, and that may be something that you want to do your dissertation on. So this next bullet, these are two of the leading um, names in print, that have come up with principles and whatnot. Gestalt was a German psychiatrist 100 years ago or more. And that's, like I said, that's a quick blog read. If you just Google Gestalt principles, that's where we start to understand the human perception, where like color, things that are the same color are often grouped together in the human mind. So we use different colors for different data series on, say, maybe a scatter plot or a clustered bar chart. We group together, like if you had, 4 departments in your company that you were comparing different things, you would use the same color for each department in all of the clustered bars that you were looking at. So Gestalt looks at like proximity, color, direction. The human mind kind of projects. There's like completion. You'll see logos that the brain fills in part of it. It's a field of study to see, to prove how the human mind perceives things. So again, some of you guys are application developers, and this doesn't have anything to do with anything. So don't worry about it. Like I said, we don't really need this stuff for the assignments. And then there's a fellow, I'm pretty sure he's still alive. He gives modern talks, Edward Tufte. I bought a video lecture from him. You can find, if you start watching or looking for Edward Tufte on YouTube, you'll be offered a video course that comes with 5 of his books. And he just talks about, data storytelling visually, and what makes things apparent to the user, what makes things stick out, what makes them important visually. And he takes into account, cognitive science. So, like I said, there's a lot of tools out there. Power BI and Tableau are the market leaders from a like a desktop application standpoint. But of course, anything new coming out that's competitive is in the cloud. So there's a lot of other, and you're starting to see a lot more interactivity. Some of the most complex but cool visualizations I've seen are web-based, and they use a JavaScript library called D3, data-driven documents. But you kind of have to be a web developer to use those effectively. You have to know other elements of web design. but they're really cosmic when it comes to displaying data. So, yeah, a lot of factors um, you can look at. You can look at um, as a researcher. You could research the effectiveness of misleading visuals, like this one. This is county level election results from 2016. Red being Republican, blue being Democrat. Remember 2016, I'm sure. Uh, Many people pointed to this graph and said, see, look at all that red. Overwhelmingly, the country voted for Donald Trump. And if you overlay this election result on a population density graph, you'll see that this is where everybody lives. These are the educated uh, metropolitan regions of the country. Um, like look down in Florida, pretty much. Miami, Tampa, and Orlando are sitting there. Tallahassee, the capital region. Um, Missing or went Republican is Jacksonville is a metropolitan area, but um, Atlanta, Washington, Baltimore, New York City, L.A., Seattle, the most populated county in Dallas, all went Democrat. So it's and we don't have elections by square footage. Who got the most square footage of votes in this country? So when you see visualizations, or if you're going to study visualizations, um, they can be distorted. They're ways to make a bad visualization. Use wrong scale, bias in the data, bias in the sampling that goes into the data visualization. But strictly from the visualization standpoint, you can show something that makes something look bad. The one I see the most is scale. They'll show a micro scale of the Dow and show it makes it look like it crashed from being worth 100 to going to zero, but it's really it just went from 32,500 to 32,400, so it lost 100 points or whatever. But if you use the wrong scale, or at least show the data in the wrong scale and talk about it inaccurately, those visualizations can be misleading. So just something to think about. Heat maps and the human eye. This is an interesting visualization. You can hook a camera up if you're a web page tester. You can hook a camera up to the computer and then show uh, anything, visualizations, web pages, whatever, to the user. And this human eye heat map will show you where and for how long people looked. And it proves that the upper left corner of anything is where, and this is a Western, a Western audience that reads left to right. So you'd have to disregard that for, I don't know, most of the world reads right to left. Anyway, the heat map for this in the Guardian's United Kingdom, it kind of proves that the human eye starts at the upper left-hand corner, like a book. But then certain things draw the eye, generally images. If you look at the images towards the top of the page, they've got a green splop on them. That means that people looked at it and kept their eye on that image for just a little while, and it registers that location and time data, and um, goes from cleared through green, through yellow, and into red. Just like when they're showing temperatures on a weather map. That's an interesting, different type of visualization. Ran into this one. It's a different way you could look at this. This is takeoffs and landings um, from major airports around the world, and the size of the circle is the number of flights, and the color is simply latitude and longitude. So it just lets you know when you're going from the Americas on the left through Europe, Africa, Asia, um, and then over into the Pacific Rim, China and Malaysia and whatnot, Australia in blue. So yeah, the dot gets bigger as the airport has more activity, and then they draw a line to the airports that airport is connected to with it, at least of one flight. So this is kind of emblematic of a different kind of data, also connected data, where the connection itself is really more important than the data. And that's a graph database. If you're inquisitive and you haven't done so already, go on YouTube and watch an hour long introduction to graph data with Neo4j. Neo numeral 4j. It's a graph database that lets you describe the connection between your nodes, and that's the way you query, that's the way you summarize data. It's not really so much about the attributes. A relational database is all about the attributes of an entity, the columns that describe a person or a product. And then we query up information based on a particular product or person, or we aggregate data, analyze data, summarize data about an attribute of all of our, say it's a customer database, all of our customers or all of our products or certain types of products. Graph database is really more about the connection. So you'll have your nodes could be people, but then your connection could be is a coworker of, which can be really difficult to decipher in a relational database. But that's the whole purpose of a graph database, is you have nodes and then you have their connection, and it could be is a coworker of, is the supervisor of. You can have different connections. Went to school with, was a student. With someone, learned data science from another person. So you have all these different connections that you can then start to look for uh, information. Look at the data, but based on the connections, and that's what this graph reminds me of. And no real mystery, because such a large proportion of, I think I've heard 70% of the Earth's population live within 50 miles of a coastline. Just because of the way ports and trade and fishing and whatnot evolved, most folks live near a coast. So when you look at this map, you can almost see the outline of continents, particularly South America and Africa. But you'll notice there are no geographic boundaries. But of course, airports are all built on land. So that, of course, you're going to see some correlation with land masses. But I just think it's interesting that it almost looks like they've drawn vector graphic maps of these continents, but they have not. So yeah, data visualization would take a giant table of data about airport codes and takeoff times and dates and destinations, and you'd make no sense of it whatsoever in your head. Throw it into the appropriate visualization, and all of a sudden you get the aha. Oh, look at the what are the largest, busiest airports um, in the world? Obviously the London, Frankfurt, Paris are all in there. But then you've got, massively busy ones over in China that you might not have ever heard of. I guess that's probably uh, Delhi and Mumbai in there. The Middle East, you can see Dubai to the left of that. And then the US, Atlanta, I'm pretty sure that giant dot is Atlanta. One thing I learned yesterday is that because of the way air freight works and the need for air freighters to refuel more often than passenger planes, Anchorage, Alaska is like in the top 5 for takeoffs and landings for cargo, even though they don't really make anything there and there's not a whole lot of people to buy things there. It's almost all refueling stops. But because of its location, Anchorage, Alaska is actually, and you can see a pretty big dot up there. So there you go. Network maps, just another interesting visualization that, and like I said, think of this like a researcher. How would you craft a research project that looked at the effectiveness of one visualization against another using the same data? How would you word that experiment, your experimental design, your null hypothesis, your alternate hypothesis, your confidence level? How would you decide? How would you frame the problem in your literature review to establish that this is something that we need to research? This would be valuable information to know how people perceive one thing over another. So there you go. Think about it like a researcher, not like somebody who's going to be using Power BI all week. Think about it like writing a real, no kidding research article. Okay, so the last sample cool visualization I wanted to show you isn't really any kind of graph that you would ever pick out of any sort of standard software. And this graph is back to 1869, drawn by a professor, I think it's Menard. Anyway, it's a map of Napoleon's campaign into Russia, jumping off from, I don't remember what river. If you Google this, there are people that have walked through this visualization in person that are more familiar with data visualization science. But anyway, the heart of it is that the pink is the Le Grand Armée during its march to Moscow, which from history class, I know we all remember that it ended badly for Le Grand Armée. So they started out with 400,000 men, I think. The pink, As you go from left to right is the advance to Moscow, and the size of the pink bar, the pink map swath, is the size of the army as it slowly died on its way to Moscow. And you can see not too far, they lost some 20,000 militiamen. They went back home. One of the generals split off for a little while, had some inconsequential action, but he lost about a third of his forces doing that, and then rejoined the formation upon its retreat. It didn't, that small group splinter in the upper side there didn't go all the way to Moscow. But anyway, you can see as they marched across the endless tundra of mostly Ukraine, that they starved and died. And when they got to Moscow, they lost a decisive battle. And the black line, starting on the right side at Moscow, they spell it Moscou. That's where you can see the retreat of Le Grand Armée throughout that winter. And it gets smaller and smaller and smaller and smaller and smaller. And pretty sure it's 10,000 soldiers got back to the river where they began, where 400,000 had left with Napoleon. So yeah, and you can even see where the troops that broke off at the top back in the first third of the campaign, when they retrograded, they joined back up with the main force, and increased its size. But then look at all the people that died on that river crossing. So yeah, so this data flows from left to right and then right to left, because it's a geographic map. It's a rough representation of where they were geographically during that campaign. So that's just a really interesting visualization and storytelling mechanism. The historians that actually study that campaign do a whole lot better job than I do. So again, if you're interested and you have time, check that out. Visualization of Napoleon's campaign into Russia. Okay, so like I said, we didn't really need to know any of that for the paper. This one, it's like I said, you'll find there are 3 or 4 that are easy to locate, where large companies have integrated big data analytics factors. You can't just sprinkle, big data software in there and just automatically fix things, but they have integrated big data analytics within their business intelligence decision-making dashboard. So your assignment is to search the UC library for a quote Fortune 1000 company. Okay. Been with the university for years, seen this assignment for a long time. Listen, Fortune 1000 is not a company. Fortune is a magazine that publishes several noteworthy lists of companies, normally by revenue, ranked by revenue. For example, the Fortune 1 company is Walmart currently. Fortune magazine publishes the Fortune 100, which is the top 100 companies. Most people are familiar with the Fortune 500. That's the 500 largest, generally U.S. companies. There are international lists as well, but uh, you need to find out what companies are on the Fortune 1000. But it's every company you've ever heard of, plus a lot that you haven't. Okay, so every company you've ever heard of, PetSmart, Walmart, Home Depot, IBM, Citibank, they're all in the Fortune 1000. But Fortune 1000 is not a company. It's a list of companies. But there's a paper out there, or more than one paper on Course Hero, that discusses Fortune 1000 as if it were a company. And that's an automatic 0. And it's copied from the original person that didn't read the instructions, that had no clue as to what they were doing, and it gets replicated. And there you go. So I'll just throw that out there for those of you that are watching the video. If you talk about Fortune 1000 company as if it were a company, you'll get a 0, because there is no such thing. You're cheating. All right, enough about that. So you'll conduct a literature review of big data analytics with business intelligence within that company you researched. So you're probably going to find a case study for that company. So I would that specifically talks about that, but you can also find other articles that just talk about analytics. I would bet that you'll have the most success with a large company like Amazon or Walmart or General Motors or Delta Airlines or something like that. So if you can get, 3 or 4 articles that talk about analytics, just talk about what they were doing. What was the bottom line? What was the result of that addition of data analytics into their big data analytics, or even traditional analytics. This paper, the instructions are very specific. So if you have questions, you can always email me. Send me a link to 2 or 3 papers that you're looking at, and I'll take a look and let you know what I think. Okay, and then the other assignment is our discussion board. Again, protecting data. Companies, of course, are still having a difficult time protecting their data from internal and external threats, and they're having trouble deciding what is sensitive, what should we be really careful about protecting, and how to set up permissions and information sharing within the company, and then how much can they make public. So this discussion is to discuss technology's impact on data security and ethics in data analytics. And that's easy enough to Google in Google Scholar and pull up some articles and discuss the issue. You're welcome to pick one impact and focus on that. But as I've said before, and I'm having notional success, follow the instructions, and when you reply to fellow students, be conversational. No more add a few points. No one wants you to add a few points to their discussion. They want you to discuss it with them as you would another professional. Okay, as always, please email me with any questions on these 2 assignments, and I will see you in class.